everyone, welcome back to our channel that is Chemical Engineering. Myself Dr. Kirti Sare. Today I am going to introduce about that how can you calculate the mole fraction, mass fraction, molecular weight of the any particularly mixture, molar concentration, partial pressure and its a mass density, right? So let's start from the problem statement. A mixture of a gas has the N2 and the CO2 kept in a container having the pressure is 200 kilopascal and temperature is 27 degrees centigrade. If the molar fraction of N2 is 0.4, so you are supposed to find the mole fraction of CO2, molecular weight of this mixture, partial pressure of the exerted gases, molar concentration of the each gases, mass density of the each gases and the total mass density and mass fraction of the each gases, right? So let us start for this particularly problems. Now they are supposed to consider the one container in which there is a mixture of the N2 plus the CO2 which is going to operate it at the pressure become the 200 kPa, that is kilopascal, and temperature become the 27 degrees centigrade, which you can convert supposed to add here, that is the 273, right? So it become the 300 Kelvin, right? This is the sum with respect to the standard unit that you are supposed to calculate it. Now the next factor they are given, that is the N2, right? N2 molar fraction they are giving the 0.4, right? Means this is here you are supposed to consider the binary system, right? This is our binary system, right? As you know that if you are going to consider the binary system, right? If you are going to consider the binary system, that is the X and the Y. So these X and the Y, it stands for the mole fraction of the mole fraction which is present into the liquid state and the mole fraction which present into the gas phase, that stand for the Y. So X stand for the mole fraction which present into the liquid phase and Y stand for the mole fraction which present at the gas phase, right? Now the first thing they are going to ask, that is the mole fraction of the CO2, and they are given the mole fraction of the N2 mixture, right? So let us start for the first one. So here if you are going to consider the any binary mixture, so for that binary mixture the summation of this X plus Y, right, or maybe the summation of the liquid state or into the gas state, so it become the 1, right? So by simply you can just calculate it the first, that is the mole fraction of CO2, it become the, now this total become the 1. So you are supposed to consider the 1 minus how much the mole fraction of the N2 they are given. So that is the 0.4, right? So if you are going to calculate simply, so you are getting value become the 0.6, right? Let's start for the calculation of the second, that is the molecular weight of the mixture. You are supposed to calculate it, which is calculated by M is equal to the Y of N2, means how much number of the moles are involving with respect to the nitrogen gas, multiply by the molecular weight of the nitrogen plus YCO2, means how much number of the Y is going to occupied by the CO2 molecules, multiply by the what should be the molecular weight of the CO2, right? You can simply calculate N2 because the mole fraction of the N2 is already given here, multiply by the molecular weight of the N2, so it become the 28 plus you are just now calculated the mole fraction, that is 0.6, multiply by the molecular weight of the CO2, it become the 44. So whenever you are going to calculate, you are getting the answer become the 37.6, become the 37.6, right? Each gases partial pressure, you are in the third you are supposed to calculate the partial pressure by the each gases. So for that you having the formula, that is the Yi is equal to the Pi by the P, right? So you have the yi value. If you are going to calculate for the N2, so N2 yi they are giving the 0.4, right? And you are supposed to calculate the how much partial pressure is going to occupied by that particularly component divided by the total pressures they are already mentioned here, that is the 200 kilopascal. If you are going to calculate the pi for the N2, that become the 80 kilopascal. And the same manner, if you are going to calculate for the pi for the CO2, so it become the moles is going to involving the 0.6. That is equal to the pi divided by the again 200. If you are going to calculate the what should be the pi is partial pressure of the CO2, so it become 120 kilopascal, right? So this is the answer for the point which can be calculated as the ideal gas law equation, which is the having the equation PV is equal to the nRT, right? Equal to N by the V, which you can also write in the form of P by the RT, right? So P is nothing but the pressure, R is the gas constant, and the T is the temperature, right? So now you can just put the all value here. The pressure they are already given, that is the 200 kilopascal, right? Now RT you are supposed to consider the 8.314. This is the universal gas constant. This unit is going to vary with respect to the what the system of the units that you have taken here, right? And temperature they have mentioned here, that become the 300 to 0.08108 kg per meter cube into the concentration for the N2. So this become the whole concentration, right? Now if you are going to multiply with this the whatever the mass fraction or the mole fraction is involving with respect to that gases, so that become the individually concentration of that particularly component, right? If you are going to calculate the CN2, so it can be calculated as the how much the number of the moles is going to involving over there. So that is 0.4 multiply by 0.08108, right? So become the 0.03207 kg per mole into the meter cube. In the same manner, you are supposed to calculate for the concentration of the CO2, which can be calculated as the 0.6 multiplied by the 0.08108. If you are going to calculate, it will become the 0.04818 kg per mole into meter cube, right? Means you are supposed to firstly calculate for the overall, and later on you are supposed to calculate for the individual. Now the is equal to the density by the molecular weight of that particularly component, right? So Ci for the N2 that you are already calculated, that becomes 0.03207, right, is equal to the density that you are supposed to calculate, and for the N2 it become the 28. If you are going to 0.0897 kg per meter cube, 0.04818 is equal to density of this you are supposed to calculate, and the molecular weight is become the 44. If you are going to calculate the density of the CO2, and this is the density of the N2, density of the CO2 it become the 2.116 kg per meter cube, right? Now what should be meter cube, right? Now the 6th point, you are supposed to calculate the mass fraction of the N2, which can be calculated as the density of the N2 divided by its total density, right? So density of the N2 you are just calculated here, that is 0.897 divided by its total density, that is 3.015. So this is 0.2979, right? And the same manner you are supposed to calculate the mass fraction of the CO2. So it become the density of the CO2 divided by its total density. So it become the density of the CO2 are calculated 2.116 divided by the 3.015, right? It become the 0.7021, right? So this is the complete solution of this particularly numerical. In that simply you are calculated the mass fraction, molar fractions, mass density and total density, individual component density, because here they are going to asking the for the binary system, and it's the mole fractions of this binary system mixture is equal to the always is equal to the 1. Please subscribe my channel, that is chemical engineering. Please share this video, and you can also ask your doubt through the comment box. Thank you so much.